How's it, grade 11s? So I'm doing these last two examples for the section exponential and logarithmic functions. So I'm doing examples 6 and 7 for you guys. Right, so instead of me writing out the whole thing, I'm just going to read it to you. So this is example 6. Okay, and it says, the strength of a radioactive source decays exponentially according to the equation S of t equals 15,000 e to the minus 0,002 t. Okay, so let's read it again. So it says the strength of a radioactive source decays exponentially according to the equation S of t equals 15,000 e to the minus 0.002 t, where t is the number of years and S is the strength of the source. Question A. Determine the initial strength of the radioactive source. So, to work out the initial strength, what would your time be initially? Well, it would be 0. So initially, t is equal to 0. So that's what we're going to work out here is S of 0, and we get 15,000 e to the minus 0,002 times 0. All right, so this will give us 0. So we get 15,000 e to the power of 0. And we know that anything to the power of 0 is 1. So we're just left with 15,000. And this thing is measuring some type of radioactivity. So we're just going to put here units, okay? So it's 15,000 and whatever the units they use to work out or measure radioactivity. Okay, so that's our first answer. So question B is determine, correct to the nearest year, how long it'll take for the strength of the radioactive source to reduce to half its original strength. So what we want to do is how long will this thing take to reduce to half of its original strength? Well, we know initially that its original strength was 15,000 units. So half the strength would be equal to 15,000 over 2. And we get there 7,500 units. That would be half its strength. So we want to work out how much time it will take to get to this. So that's what I'm going to make S of t be equal to. So we're going to say S of t will equal to 7,500, and we'll solve for t. Now we know what S of t is equal to. It's equal to this expression over here. So we get 15,000 e to the minus 0,002 t equals 7,500. And what we're going to do here is we're going to solve for t. Okay, so first of all, I divide through by 15,000 and we get e to the minus 0,002 t equals then 7,500 divided by 15,000 gives me a half. Okay, now grade 11s, what I'm going to do is I'm going to use our log or our exponential conversion. Okay, now because we're dealing with e, remember we're going to be using the natural log. Okay, and I'm just going to recap over here. If we've got a to the y is equal to x, that means that y is equal to log x base a. All right, and what we can do is we can swap between those. So at this stage we're over here and I'm going to convert it to logs, but now remember we're not going to use logs, we're going to use ln instead because we've got base e. So this is going to be negative 0,002 t is equal to ln a half base e. Now remember, I don't have to put the base e in there because ln's base is automatically e. So what I can do now is I can say t is equal to ln a half over minus 0,002. This I can put on the calculator and I'll show you how we do that. So first of all, it's a fraction ln, and we've got inside that another fraction, and it's a half. And at the bottom, we've got negative 0,002. And the question was to the nearest year. So in this case, the nearest year, I'm going to bump that up because that's 5. So it's going to be t is approximately equal to 347 years. So it'll take this, whatever this stuff is, 347 years to get half of its strength. Okay, and that's basically what we call the half-life of something, which you'll probably learn in chemistry. All right, so you see how math is incorporated with that, especially with exponents. Now, this is the power of where these exponential equations come into. All right. Okay, guys, going on to example 7. I'll read it out to you. The number of insects n in a colony after t weeks is given by this formula. N of t is equal to 150 over 2 plus 13 e to the minus 0,4 t. Okay. It goes on to say, question A, how many ants were in the colony initially? So remember, initially t is equal to 0. So that means we're going to be finding n of 0. We get 150 over 2 plus 13 e to the minus 0,4 times 0. All right, grade 11. So what I'm going to do is I'm just going to miss a few steps here. So that minus 0,4 times 0 is just 0. E to the 0 is 1. 1 times 13 is 13. 2 plus 13 is 15. So we get 150 over 15, which gives us 10. So initially there were 10 ants in the colony. Okay. Question B. How many ants to the nearest hole will there be after 5 weeks? So now we've got t is equal to 5. So I'm going to be finding n of 5, and we get 150 over 2 plus 13 e to the minus 0,4 times 5. Okay, this you can just put on your calculator. So 150 over 2 plus 13. Now your E button is over here, so you have to press Shift E, and this is to the power of negative 0,4 multiplied by 5. Then what we want to do is it's saying how many ants to the nearest hole will there be after 5 weeks. So the nearest hole of this would be 39. Now I know you guys are probably saying, no, it's 40. Well, it can't be 40 because we can't make up 0.1 of an ant, okay? We can't just make that out of thin air. So there are 39 full ants and like 0.9 of an ant. So our full number there would be 39, okay? Then question C. After how many weeks will there be 60 ants? So what we want to do is we want to say n of t is equal to 60. And we know what n of t is. It's this 150 over 2 plus 13 e to the minus 0,4 t equals 60. And what we want to do there is we want to solve for what t is now. All right, so what I'm going to do is I'm going to multiply up by this and divide by 60. So I'm just going to be doing 2 steps in one. So we get 150 over 60 equals 2 plus 13 e to the minus 0,4 t. And again, grade 11, so I'm just going to miss some steps here, but I'll talk through it. I'm going to work out what this is. I'm going to subtract 2, then divide by 13. Okay, so we've got 150 over 60. Subtract 2 from that. I'm going to get an answer, and then I'm going to divide by 13. And we get 1 over 26 is equal to e to the minus 0,4 t. All right. I'm going to convert this just like I did with the previous one. You remember if we got a to the y is equal to x, that means that y is equal to log x base a. Okay, but I'm not going to be using logs. I'm going to be using ln because we've got the base e here. So we've got minus 0,4t is equal to ln 1 over 26 base e. We don't have to write the base e. I can work out what t is equal to. So we've got a fraction and it'll be ln 1 over 26. Divide that by negative 0,4. And to the question was after how many weeks. So this will be 8 weeks. Okay, so 8 weeks. There will be 60 ants. I think I can squeeze in the last one here. Okay, so question D is saying, what is the eventual number of the ants in the colony? So what is our time going to then if we look at the ants that'll be in the colony after so many years? Well, what I'm going to do is I'm going to make time tend to infinity. Okay, now if we go back to this and we just have a look, which thing is dependent on the t? Well, it's this whole exponent thing over here, e to the minus 0,4 t. Now if I make that t tend to infinity, infinity times negative 0,4 is still negative infinity, all right? It's just the 0.4 is not going to make any change to the infinity. So it's negative infinity. Now, that means because it's negative infinity, this will be 1 over e to the infinity, okay? So that means, this implies that this thing will become 1 over e to the infinity, okay? Now, e to the infinity is a very, very, very large number. 1 divided by that huge number is 0. So basically, that's 13 times 0, okay? And it's that will just fall away, basically. So what we've got here is n of infinity would be equal to 150 over 2 plus 0. Okay, because that whole term falls away. So we've got here 150 divided by 2, and we get 75 ants in total. All right, so grade 11, so that's the end of the exponent section. What you can do for me now is you can do all of this for me. You can do question 5, 6, and 7 for me, please. Thank you.